The first thing that we're going to do, the first model on this page is the Cox Proportion-Hazard Model. So I'll use this one to debunk or prove one of the common misconceptions in my country, which is Malawi, whereby we say that independent women have the high divorce rates. So basically, these are the variables that we have. So if we can try to delve much into some of the variables, like there's case ID, which is the unique identifier. There's total nominal per capita consumption. So this one is a proxy for income. And the gender one, so the gender, as I said, that I'm restricting to females only due to the whole concept. So it's our subsample. On age, that's the timeline. It's a proxy for the timeline. Education level, it's categorical. Much on that one. So we do use code book. Code book gives a simple description of the variables you have. So education level, we have none, or the never, which never attended school, the 2 for primary, 3 for secondary, and 4 for tertiary. Moving forward to marriage type, we have 5 categories. Though all these categories are coming from only 2, which is the matrilineal and the patrilineal. I also like to use code book than tab or sum because code book has that versatility in terms of whereby it gets to show you everything that you are looking for. Then we have the urban-rural divide, which is a binary one. Income, as already explained. Then we have the rich females. So these rich females are the ones whereby if their income is falling within the 90th quintile. The fun part about hazard model is it has 3 key steps. So the first one is to define the data as a survival analysis. So how do we get to define that? So on this one, use the command stset. So it's like survival time set, or stset. Our time variable is the age, right? I'd have used marriage duration, but I think we had issues of missing data on that one. That's why I'm using age as a proxy of marriage duration. So we've used age. Then we specify the options which define our event. I don't know why they call it failure, but anyway. So our event is the marital status, whereby we're saying that whether one is divorced or not. So that's the event. So it's the time, age, and our event is the marital status. The thing, guys, that I always get to do is I don't overlook the usage of weights. It's something which most people will get to overlook, but for me, I'm always very critical of using the weights because this at least gives a robust structure for our data. You can use the P or the I, that's based on the IHS data. So we're talking about P weight. So this is our weight. Then get to. So guys, this is the command we have to declare that our data is survival data. So that's what we have. So once we define our data survival data, the second step that we get to do is to now regress it with the covariates or the independent variables. So this one, the whole defining our survival data is more like we're defining even the dependent variable. So the next step on it includes the independent variables, which are the rest of the variables I was talking about. So on this one, we use the xtcox command, right? So xtcox. So now let's first define. So we have our first variable, it'll be education level. The second step we have is marriage type, which is the societal pressure towards household decision making. The other one is the urban-rural divide. Then we also have the rich females variable. One thing I also like to do, I always like to keep my standard errors as robust as I can. So this is what we have. Hopefully you can see my cursor. So the first one, you can see this one where it's called prob greater than chi squared. On that one, if it shows that the model is significant. So moving forward to the variables, they have a unique way of interpreting them. So how we interpret the hazard ratios is we subtract the ratio with 1. Like, for example, we have education level primary is significant, which is 1.53. So if we subtract 1, it gives us 0.53. So once you subtract it and it gives you a positive, that means the risk is higher. But once if you subtract it and it gives you a negative, that means the risk is lower. So moving towards the marriage type, on that one, we only have one significant, which is the patrilineal and patrilocal. So on that one is lower with, like I say, so it's 0.33 minus 1. On that one, if I can estimate some quick maths, that gives us 0.67, right? I think it's minus 0.67. So that means it's lower with 67%. Wow. Similarly, on rich females. So rich females is also lower with 22%. Oh, so basically that's the direction of our variables. However, we can consider robust check, whereby for some variables where we feel like it's different from the theoretical framework, so maybe we are looking to delve much into the variable, we get to do a robust check towards it. So for me, I think the one which I'm a little bit skeptical towards is the females. So on that one, I think we get to the third step of the model. This one we use graphs. Moving forward to the graph, we use the stcurve command. So when it comes to the options, we have two options. We have the survival option and the hazard option. So mostly I use them based on the direction of the ratio. So when you use the hazard, that means it focuses on the event occurring, which is the 1. While the second option is survival, which focuses on the event not occurring, which is the 0. For this one, for the rich females, it's a negative because there's a risk of the event occurring. So I'm using the survival to focus now on the 0. Hopefully that one is clear. Once you get there, I think we have to also specify the graphs. That means the first and the second graph. So if it is based on the coding of the variable. So on the rich females, I said is 1 and 0. That means the first graph I choose, for me, that is I choose it to be 1, which is equal to 1. So the second graph is obvious that it's 0 now. So basically, this is the survival. So when you're interpreting this, we're focusing on the survival. In our case, it's marriage. So basically, from the graph, it shows that if you look at rich females, it shows a better survival rate. So for rich females, they're most likely to be in a marriage compared to their counterparts. I think in an easy way, I can also define this. Let's just look at 40, the analysis time, or 40 years, right? So if I'm moving 40 to here, to the first intersection of the lead line, you see that it's around 5 for the survival, 0.5, almost 50%. While if we look at the same 40 for the rich females, which is the 1 now, it's around 6, so there's a difference of 10%. Most likely for me to conclude to say, when it comes to the rich females, they have less risk to divorce. I won't explain much on the results based on what I think. Hopefully this will be left for everyone else to try, or to give a perspective of why they think the results are this. Thank you for listening. Hope we have a more interactive session in the comments. Thank you.